Okay, so today we're going to cover Chapter 1, Section 6A. And again, I'm only going to work out the first 8 examples with you today. And then on Thursday, we will finish Section 6A. So today we're going to be solving other types of equations, and more specifically, polynomial equations. So most of the polynomial equations can be factored. Always look for a GCF first. And then if you can pull a GCF out, then factor what remains. If what remains cannot be factored and it's quadratic, then you could use completing the square or quadratic formula. Now, the third bullet point here, it says if the variable on the first term is the square of the middle term, we can use substitution to simplify the polynomial. This is what I'm going to teach to you, this third bullet point, on Thursday, and this is called U substitution. So again, all of this, when we're solving these polynomials, is leading us into graphing the polynomials. Because when we solve these polynomials, what we're really finding is the x-intercepts. A lot of times on a standardized test, you may see them say, solve the polynomial, find the zeros, find the roots, find the x-intercepts. And essentially, what we're doing today is doing all of that. So this is where the instructions can get kind of confusing. So here is our first example. So again, if you don't have the Wi-Fi, go ahead and just open blank Notability, write down the problem. So what we need to do is solve for x. Now, notice the largest exponent on the variable that we have will tell us how many solutions we're going to find once we're done. So once we're done, we should potentially be getting 4 answers. Now, I need to set my equation equal to 0. So I'm going to go ahead and subtract the 48x squared from both sides. And I get 3x to the 4th minus 48x squared equals 0. My next step is to try to factor this. I could actually factor out a greatest common factor of 3x squared. So that's what I'm going to factor out first. And then I'm going to see if what remains behind is something that can still be factored further. And it can. I've got the difference of 2 squares. So now I'm going to continue factoring 3x squared and then factor the x squared minus 16 into x plus 4, x minus 4 equals 0. Now we've already done this in the prerequisite chapter. The only difference now is we're going to take it one step further and set each one of our factors equal to 0 and solve for x. So I'm going to take my first factor, that GCF, 3x squared, set that equal to 0, set the x plus 4 equal to 0, and then the x minus 4 equal to 0. For the first one, divide by 3, and I get x squared equals 0. Technically, what I should be doing here is square rooting both sides, and I should be getting plus and minus 0, but there is no positive or negative 0. So actually, this is counting for 2 of my answers. And then next, I'm going to subtract the 4. So my next answer is x equals negative 4. And then finally, for the final answer, x equals 4. So I have technically 4 answers. 0 counts for 2 of them, and then the positive and negative 4. When we go to graph polynomials like this x equals 0, because technically it occurs 2 times, when we go to graph it, this is not going to cross through the x-axis at 0. It's actually going to come down, touch the x-axis, and then bounce away. But we're going to be seeing this coming up. When your answer that you get for x occurs 1 time, this is where it's going to cross the x-axis. So this is actually touching the x-axis at 3 different points. So for number 2, the problem is 9x to the 4th minus 12x squared equals 0. So again, this one's already set equal to 0 for me. Notice I do not have the difference of 2 squares here, but I do have a GCF that I can divide both of them by. I can divide both of them by 3x squared. So that's what I'm going to do, is factor out the GCF first. What remains is 3x squared minus 4 equals 0. What remained after the division is not the difference of 2 squares, so I'm finished factoring here. So now I take each factor, set them equal to 0. So the 3x squared equals 0. The 3x squared minus 4 equals 0. And now I'll begin my solving process. Divide both sides by 3. I'm left with x squared equals 0. I need to square root both sides. And again, I end up with x equals 0. I'm not going to put plus minus 0 because I don't have a positive and negative 0. So again, this counts for 2 of my solutions. Over here, I'm going to add the 4. X squared equals 4. I need to isolate that x squared, so I have to divide both sides by 3. I get x squared equals 4/3. I'm going to use my square root method. I'm going to square root both sides. I can square root them separately. So then this gives me x is equal to positive and negative 2 over the square root of 3. Remember, you can never ever leave a square root in the bottom. So I need to multiply the numerator and the denominator by the complex conjugate. That complex conjugate is the square root of 3. So once I multiply it, my final answer is positive and negative 2 times the square root of 3 over 3. So I have 2 answers right here, and I have 2 over here, but I'm only going to list it once. When you do go to do the 1.6 homework, you're going to separate your answers with commas. It's already set equal to 0. So I'm going to go ahead and rewrite it, and I'm going to make my 2 groups. So I have x to the 3rd minus 3x squared plus 3x minus 9 equals 0. I'm going to make a red group and a blue group. I'm going to look for my greatest common factor of my red group. That is going to be x squared. I'm going to divide it, and what remains is x minus 3. I'm now going to look for my greatest common factor of the blue group. It will be 3. Divide. And again, remember, when you factor by grouping, what remains after you divide must match. And it did. So go ahead and you can take your 2 GCFs. They become a binomial. And then what was in common is the other binomial. And now I set each of my binomials equal to 0. X squared plus 3 equals 0. And the x minus 3 equals 0. I'll solve for x, subtract the 3. X squared is equal to negative 3. Using the square root method, square root both sides. I now know how to square root a negative number, and this ends up being x is equal to positive and negative I square root 3. Solve the other one. Add 3 to both sides, and x equals positive 3. Notice what we started out with. My largest exponent here was an x to the third. This was a clue that I needed 3 answers. So I actually have two imaginary answers and 1 real answer. So again, WebAssign will expect you to pull it apart. So negative I square root 3, comma, positive I square root 3, comma 3. WebAssign tells you to separate the answers with commas. Your next problem is x to the third minus 5x squared minus 2x plus 10. Let me rewrite it, and then I'll make my groups. So I've got a red group and a blue group. My greatest common factor of the red group is going to be x squared. So I'm going to divide them both by x squared. My greatest common factor of the blue group is going to be negative 2. Because remember, if I just pull out a positive 2, I will not get x minus 5 as the result. But if I factor out a negative 2, then I've got the match that I needed. These needed to be the same. So go ahead and take the 2 GCFs, put them together, and then what was in common after you divided. I now set each one of the factors equal to 0. So x squared minus 2 equals 0, and x minus 5 equals 0. I'm now going to solve by adding 2 to both sides. X squared equals 2. Square root both sides. And don't forget that it's x is equal to positive and negative square root 2. Over here, add the 5, and x equals positive 5. So again, we started out with an x cubed. I'm looking for 3 solutions. I have negative square root 2, I have positive square root 2, and then positive 5. So for number 5, again, check it out, see if it's something that you can pull a GCF out. And there is. I can divide all of these by 3x. So let me start by doing that. And then I'm going to see if the trinomial that remains can still be factored. So I'm going to divide all of them by 3x. What remains is 2x squared minus 9x minus 18 equals 0. I'm now going to factor the trinomial. I can factor by grouping. So what I can do here is multiply the 2x squared and the negative 18, which gives me negative 36. So I'm looking for 2 numbers that are going to multiply to give me negative 36. Now you could think of it as negative 36x squared. That add to give you negative 9x. So now what I'm going to do here, those factors are actually going to be positive 3 and negative 12. So now it doesn't matter the order that you place them in. So now I'm going to, don't forget about your GCF. So I have the 3x here. I'm going to rewrite the 2x squared. You're replacing the negative 9 with the 2 factors you just found. Negative 12x, positive 3, and then rewrite the 18. And now you can factor by grouping. I'll make a red group here and a blue group. Don't forget about the GCF. Keep bringing him down. GCF of red is going to be 2x. Divide it. My GCF of my blue group is going to be 3. Still equal to 0. And now you're going to take the 2 GCFs. That becomes your first binomial. And your second one is what was in common. And now it's fully factored. And now you'll set all three pieces equal to 0. Because again, remember, we started out with an x cubed. So we're looking for 3 answers. So I'm setting the GCF equal to 0, 3x equals 0, divide. My first answer is x equals 0. Set the 2x plus 3 equal to 0. Subtract the 3. 2x equals negative 3. Divide by 2. And my second answer is negative 3/2. And then finally the last one, x minus 6 equals 0. Add the 6. And x equals positive 6. So I have x equals 0, negative 3 over 2, and then positive 6. 3 answers. So the next one is x to the 4th minus 3x squared plus 2. So I'm going to go ahead and I could just guess and test here and then get to my binomials, but I'll show you factor by grouping so nobody gets lost. So if you do factor by grouping, you'll multiply the beginning and the end. So I'm looking for two numbers that will multiply to give me 2x to the 4th, but who will add to give me negative 3x squared. So those two factors are going to be negative 1x squared and negative 2x squared. So now, if I factor by grouping, and I'm going to show you guess and test right below it. So if I do the factor by grouping, I'm going to go ahead and get x to the 4th, rewrite the first term. I'm replacing the middle here with these two terms. So 1x squared minus 2x squared, and then the last term, the positive 2. And this all equals 0. Make a red group and a blue group. And then now GCF of the red group is going to be x squared. So x squared and then x squared minus 1. GCF of blue is going to be negative 2. X squared minus 1. Take these two, put it together, and then the 1 in common. So that gets me my factors. Now, if you recognized that this was an easy trinomial with a 1 in front of the x to the 4th, you could have just done this. Done the guess and test, set up the binomials. Factors of x to the 4th are x squared and x squared, and then factors of 2 that give you negative 3 would have been negative 1, negative 2. And it's the same thing you got when you factored by grouping. So you can do it either way. So then now that we have it factored, I'm going to take each one of these guys and set it equal to 0. So for the first one, I can't factor it, but I can use my square root method. So x squared equals 2, square root both sides, and the first solution, or first two solutions, are positive and negative square root 2. Now, for the next one, I could solve it the same way, or I could factor it. It's the difference of two squares. The choice is yours. So you could either add the 1 and do like we just did, square root it, and x equals positive and negative 1. Or the other way to factor this could have been x plus 1, x minus 1, and then set each one equal to 0. Either way, you're going to get positive 1, negative 1. It doesn't matter how you solve for x when you have the difference of two squares. And you get the same answer as that. So my 4 answers are positive and negative square root 2 and positive and negative 1.
Why is it square root 1?
All right, number 7, same thing. So you can either choose to factor by grouping, or if you recognize that really all we need to do is look at the factors of 12, that will give me -7. And those factors are going to be, for the x to the 4th, it's x squared times x squared. And then for the factors of +12, that give me -7, that's going to be -3 and -4. Set each one equal to 0. You can do it by grouping as well. You're going to get the same two factors. And then here, add the 3. That's not the difference of two squares, so I have to use the square root method on this one. And then when you square root it, x is equal to positive and negative square root 3. However, for the next one, you can either solve it the same way or factor it into x plus 2, x minus 2, and solve it this way. It doesn't matter when it's the difference of two squares. So -2, x equals -2, add the 2, and x equals +2. So my four answers, negative square root 3, positive square root 3, -2, +2. And again, you're separating all the answers with commas when you enter them into WebAssign. One last example that we'll do today. This one is another trinomial. At first glance, you may think it is a perfect square trinomial, but it's not. So for this one, I am going to factor by grouping. So I'm going to multiply the beginning and the end. This gives me two numbers that will multiply to give me 36 x to the 4th, but who will add to give me -37 x squared. And those two factors are going to be -1 x squared and -36 x squared. Never look over the obvious. So this is what I'm replacing the middle with. So rewrite the first term, 9x to the 4th. Replace the middle with the two terms. It doesn't matter if you put the 1 first or the 36. You'll get the same answer either way. Make your groups. My greatest common factor of the red group is going to be 9x squared. Divide it. The GCF of the second group is going to be a -1, because remember, you want it to look the same. And now take the two GCFs you just divided by. They become the first binomial. And then the second one is the one in common. Notice both of these are the difference of two squares. So again, on both of these, you can either factor them or use the square root method. It doesn't matter. I'm just going to factor them. So this will factor into 3x minus 1, 3x plus 1, and this one will be x plus 2, x minus 2, and now set all four binomials equal to 0. So 3x minus 1 equals 0, 3x plus 1 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So I'm going to solve all of them. So I'm going to add 1. My first solution after I divide is x equals positive 1/3. Do the same thing here. First subtract though, then divide, and x equals negative 1/3. Over here, subtract 2, x equals negative 2, add 2, and x equals positive 2. Again, you could have used the square root method. You could have added the 1 and then divided by 9 and then square rooted it. Either way. So these are your four answers after factoring that trinomial.